السلام عليكم ورحمة الله وبركاته أعزائي طلاب الصف الثالث ثانوي. Today inshallah we complete exercise on the first derivative of the trigonometric function. Question number 5, find the first derivative for each of the following. Letter A, y equals 1 plus cotan x all power 2. This function is function raised to the power 2, so it's a first derivative. We drop the power and subtract 1 from the power times the derivative of the base multiplied by the derivative of the angle. So the result will be 2 times 1 plus cotan x times negative cosec square x plus 1 times 1. We can simplify this result to be negative 2 cosec square x multiplied by 1 plus cotan x. Letter B, y equals 3 minus 2 cotan x whole power 2. Also this function is function raised to the power 2. So the same way we drop the power and subtract 1 from the power multiplied by the derivative of the base of the function. So the result will be 2 multiplied by 3 minus 2 cotan x times the derivative of negative 2 cotan square is negative 2 multiplied by negative cosec square x times 1. And we can simplify this result to become 4 cosec square x multiplied by 3 minus 2 cotan x. Letter C, y equals cosec x plus cotan x all to the power negative 1. Also this function is, the base is cosec x plus cotan x raised to the power negative 1. It's the first derivative y dash with the power negative cosec x plus cotan x all to the power negative 2, subtract 1 from the power, times the derivative of the base derivative of cosec x is negative cosec x cotan x, and the derivative of cotan x is negative cosec square x, times derivative of the angle that is equal to 1. And we can simplify this expression by taking negative as a common factor from the second factor and multiplied by the first negative, so the final result will be cosec x times cosec x plus cotan x all to the power negative 1. Letter D, y equals tan cotan x. This function is trigonometric function tan and its angle is cotan x. To find its derivative, we label to it by y dash, and we studied the derivative of tan is sec square the same angle cotan x multiplied by the derivative of the angle. Derivative of cotan x is negative cosec square x multiplied by the derivative of the angle that is equal to 1. And we can simplify this exercise, or the result, it is equal to negative cosec square x times sec square multiplied by cosec square, and its angle is cotan x. Letter E, sorry. Y equals the cotan of cosine 3x. So its derivative we label to it by y dash, and the derivative of cotan is negative cosec square for the same angle cosine 3x multiplied by the derivative of the angle. Derivative of cosine 3x is negative sine 3x times 3. 3, it is the derivative of the angle 3x. Also, we can simplify this answer to become 3 sine 3x cosec power 2 for cosine 3x. Next exercise, letter F, y equals sine of cosec 3x power 2. The first derivative of sine is cosine the same angle cosec 3x power 2 multiplied by the derivative of the angle the cosec 3x power 2. Its derivative is negative cosec 3x power 2 cotan 3x power 2 multiplied by the derivative of the angle derivative of 3x power 2 is 6x. And we can simplify the result to become negative 6x cosine of cosec 3x power 2 times cosec 3x power 2 cotan 3x power 2. Exercise number 6, find the slope of the tangent to the curve of the function f where f of x equal 2 cotan x plus root 2 sec x at x equal pi over 4. The given function, its rule is y equal 2 cotan x plus root 2 sec x, and you have to find the first derivative. The derivative of we label to it by y dash. It is equal derivative of cotan is negative cosec square negative 2 cosec square x plus the derivative of sec is sec x tan x multiplied by root 2. And by substituting about the value of x that is equal to pi over 4 to get the slope of the tangent. Slope we label to it by m. It is equal to dy by dx at x equal pi over 4 equals negative 2 cosec square pi over 4 plus root 2 sec pi over 4 tan pi over 4. And you can use the calculator to find the value of the slope that is equal to negative 2. The request is find the slope, so the slope of the tangent at x equal pi over 4 is negative 2. Exercise number 7, find the slope of the tangent to the curve of the function f where y equal 3 tan x minus cosec square x for x equal 3 pi over 4. Letter B, y equal 3 tan x minus cosec square x at x equal 3 pi over 4. First step, we find the first derivative of the given curve. Dy by dx, derivative of tan is sec square 3 sec square x minus derivative of sec square, we drop the power 2 cosec x multiplied the derivative of the base that is equal to negative cosec x cotan x multiplied by the derivative of the angle that is equal to 1. dy by dx equals 3 sec square x plus 2 cosec square x cotan x. It is the final result for the first derivative of the given function. To find the slope, we label to it by letter m, and we know the slope. It is the value, the numerical value of the first derivative at x equal 3 pi over 4 in radian measures, that is equivalent to 135 degrees. And it is equal 3 sec square 135 plus 2 cosec square 135 cotan 135. And by using the calculators, the answer become 2. So the slope of the tangent at x equals 3 pi over 4, its numerical value is 2. Exercise number 8, complete. Letter A, d by dx for 5 minus 2 cotan x all power 3. This function is raised to the power 3. So its derivative, we drop the power and subtract 1 from the power, multiply it by the derivative, the first derivative of the base. So the answer will be 3 times 5 minus 2 cotan x whole to the power 2 multiplied by negative 2 times negative cosec square x. We can simplify this result to become 6 cosec square x times 5 minus 2 cotan square cotan x all to the power 2. Exercise number 5. If y equal cotan pi over 6z and z equals 3 root x, find dy by dx at x equals 1. This curve is a composite function, so first step we find the differentiation, or we can substitute about the value of z in the first function. So y equals to cotan pi over 6 and substitute about z by 3 root x. In the simplest form, it is equal cotan pi over 2 root x. We can rewrite this function in the form cotan pi over 2x to the power half. Y dash dy by dx, it is equal negative cosec squared pi over 2x power half times pi over 4x power negative half. So the first derivative at x equal 1, we substitute by the value of x by 1 to get the numerical value of this exercise to be negative pi over 4. Exercise number 10. If y equals root 5 minus 2z and z equals sec 2x, prove that root 3 dy by dx plus 12 equals 0 at x equals pi over 6. First, we can rewrite y in the form y equal root 5 minus 2, substitute about z by its value, sec 2x all to the power half. This function is raised to the power half, so its first derivative we drop the power half, subtract 1 from the power, it means a half multiplied by 5 minus 2 sec 2x all to the power negative half, multiplied by the derivative of sec is negative 2 sec 2x tan 2x multiplied by 2. So the slope m equals dy by dx equals 5 minus 2 sec 60 degree to the power negative half times negative 2 sec 60 tan 60 degree. By using your calculator, scientific calculator, you can find the value of the slope, that is equals negative 4 root 3. Substitute by this value in the left hand side of the request, that is equal root 3 multiplied by dy by dx, its value is negative 4 root 3 plus 12, that is equals root 3 times root 3 is 3 times negative 4 is negative 12 plus 12 equals 0. It is the value of the right hand side. Exercise number 11. If y equal root 14 minus 5z and z equals cotan 2x, prove that 3 dy by dx minus 10 equals 0 at x equals pi over 8. First, we can rewrite the value of y. It is equal 14 minus 5, substitute about z by cotan 2x all to the power half. After that, the first derivative is half times 14 minus 5 cotan 2x all to the power negative half times 5 cosec squared 2x times 2. In the simplest form, it is equal to 14 minus 5 cotan 45 degree all power negative half times 5 cosec squared 45 degree. That is equal 10 over 3. After that, substitute by this value in the right hand side of the request. It is equal 3 multiplied by 10 over 3 minus 10. It is equals 0. The value of the right hand side. Last exercise. If y equal cosec n, cosec power nx, prove that dy by dx plus ny cotan x equals 0. Solution. Y equal cosec x all to the power n. It is a function raised to the power n. So dy by dx equal n times cosec power n minus 1 times negative cosec x cotan x. dy by dx equal negative n times cosec power n minus 1 is cosec power n times cotan x. So the left hand side of the request is dy by dx. We can substitute about it by this numerical of this value, that is negative n times cosec power n times cotan x plus n cosec x over power n times cotan x, that is equal 0, the value of the right hand side. At the end, thank you for listening, and I hope to see you next session, inshallah. Wassalamu alaikum.